Now we are on MITRE ATT&CK Framework, CySA, Threat Mapping Essentials. We're on MITRE ATT&CK Framework. For MITRE ATT&CK Framework, what is MITRE ATT&CK Framework? MITRE ATT&CK stands for Adversary Tactics, Techniques, and Common Knowledge is a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. It serves as a foundation for development of specific threat models and methodologies in the private sector, government, and cybersecurity product and service communities. We have framework origins. MITRE Corporation first released in 2013. Current version 14 as of 2024. We're in 2025, about to be 2026. Core philosophy, evidence-based, built from real-world cyber attack observations. Standardized language, common vocabulary for describing adversary behavior. Community-driven contributions from global cybersecurity community. Platform agnostic, applicable across different operating systems and environments. Framework structure and components. The attack matrix is a thing that organizes adversary behavior into a structured format with 3 key dimensions. Tactics, the why. So these are all like the tactics that they use. Techniques are how they do it, right? Maybe some targets that they use, right? Primary use cases. Initial access, app store delivery, right? Industrial control systems, right? These are like control systems like that actually control, industrial control systems are like manufacturing and other industries like that heavily rely on industry systems. I think manufacturing whenever I think industry systems, right? Here's the phishing initial access, right? Spear phishing attachment, spear phishing link, spear phishing via service, detection opportunities, email gateway, exploit public facing application, right? They got SQL attacks, cross-site scripting, remote code execution vulnerabilities, authentication bypass, direction opportunities, web application firewalls, network intrusion detection systems, persistent techniques, boot or log on auto start execution. So this could be an auto start that changes registry keys, right? Whenever it runs, it boots up. It could be a boot process, which probably mean like it's a rootkit or something that runs in memory, right? Rootkits can run in memory, right? Process injection, right? When I think process injection, I think overflow, buffer overflows, right? Dynamic link library, portable executable injection, process hollowing. I guess they're injecting or making the program a little bit bigger so that it'll overflow into another sector and do something. For process behavior analysis, right? Those are how it detects it, right? Credential access, OS credential dumping. They're trying to get those passwords from your operating system, right? With LSAS. So these could be like the techniques. LSAS process memory. Different tools that the attackers could be using. Security account manager. And NTDS, right? Memory protection. You might use secure boot. Stuff like that can help you, right? Cozy Bear. Oh, this attack's notable, right? SolarWinds supply chain attack, right? The Cozy Bear. And attribution by Russia, the SVR. Active since 2008, right? One of their campaigns was the SolarWinds attack, which is a crazy attack how they did it. They sent a spear phishing link that then opened up a PowerShell that ran registry run keys that had a DLL injection into the web browser so that they could have a command and control server, which is a very sophisticated attack right there, right? APT1 commitment crew, China, active since 2006. Campaign was intellectual property thief. So what were they trying to steal? Were they trying to steal like government documents, like confidential stuff, or top secret? They were trying to steal that top secret stuff. But they sent a spear phishing attachment, which opened up the Windows command, like command prompt, right? Which scheduled a task to embed itself in LSAS memory to exfiltrate data over a command and control server channel. So for Fin7, we have attribution financially motivated cyber criminal group, active since 2013. Notable campaigns, point of sale malware campaigns. When I say since 2013, that's just estimated. You don't know if they're still operating. You just know that's since the last attack that they did, right? That has actually been detected. So what they did is they attacked point of sale point of sale malware campaigns, right? They sent a spear phishing attachment with a malicious file. They obfuscated the files or information. They then screen captured it, right? Then they destroyed that data after they exfiltrated it, right? Banking Trojan and botnet first observed 2014 distribution spam campaigns. Emotet. Spear phishing attachment. You can kind of see how all these are common. They're all using these like spear phishing attacks. The next one we're getting into, the Ryuk ransomware, just disables or modifies tools. So they had to like actually go on there and get it. They didn't have to send it through an email. So Ryuk ransomware had to actually deliver the malware themselves, right? So then they open up a Visual Basic document. They inject something into a process, maybe by DLL injection, I don't know. System information discovery. Then they attack the web protocols, get data from that, right? Doesn't say nothing about a command and control server, so I don't know how they're getting that data back, other than from a website that's sending it back to them, right? So they had to actually deliver this malware, because it doesn't say how it got on the system, right? The malware disables or modifies tools, then it goes to file and directory discovery, then it encrypts the data, then it transfers the data to the attacker. So it encrypts the person's data and sends it to the attacker. The attacker knows the encryption key, so he could either sell that data on the dark web, stuff like that, which wouldn't be good. We have practical applications of attack. Threat modeling, risk assessment, stuff like that. We have map organizational assets to attack techniques. Identify critical attack paths through the environment. Access technique feasibility in current environment. Prioritize defensive improvements based on risk. There's an example on some of the stuff, how these certain indicators indicate spear phishing, right? 2 user execution, 2 DLL injection, 2 domain accounts, 2 RDP, 2 NTDS, then 2 exfiltration. So there's different ways, there's different variations of attack frameworks, right? Coverage, defensive control mapping, prevention controls, techniques blocked before execution, detection controls, techniques monitored and alerted, response controls automated, response to technique detection, recovery controls, techniques for system restoration. Red team and purple team exercises, select target organization type and vertical, choose relevant threat actor profile, map plan techniques to attack framework, design attack progression through tactics, document expected detection and evasions for purple team and red team. Purple team, validation, some of the stuff you can do there. An example of LSAS memory dumping, attack informed hunting, select high risk techniques on threat intelligence, develop hunting hypotheses across specific techniques, create detection queries for technique indicators, hunt proactively for technique evidence, document findings and improve detections. Example, process hollowing, right? Security control assessments, MITRE ATT&CK evaluations, right? Coverage gap analysis, right? Attack Navigator is an open source web application that provides basic navigation and annotation of attack matrices. It allows users to visualize and share attack data. Visualization capabilities. Techniques highlighting color coding based on various criteria. Custom scoring assign numeric scores to techniques. Layer management. Multiple overlays for different perspectives. Export options. SVG, Excel, and JSON formats. Use cases. Threat actor mapping visualize specific group capabilities. Coverage. Assignment, show detection, and prevention coverage. Red team planning. Plan attack paths and technique selections. Training materials. Create educational visualizations. Custom layers, detection coverage layer, right? Threat actor analysis. Integration with security tools. SIEM integration, Splunk attack integration. Attack app for Splunk. Pre-built dashboards for technique visualization. Attack tagged detection rules. Threat actors to technique mapping. Coverage assessment reporting, right? Example of attack tagging, right? So it's showing like the different vulnerabilities and stuff, or the attack methodologies, right? Elastic security attack integration. I assume they're talking about Elasticsearch, Elastic built-in features, attack rule library with technique mapping, detection rule dashboard, and organized by tactics. Threat intelligence enrichment, attack context, timeline integration, analysis with technique annotations. MISP attack integration, right? Endpoint detection and response. Attack-based detection rules. Attack CrowdStrike Falcon. Built-in attack technique detection. Custom indicator of attack creation. Indicator of attack? I never heard of that. I just heard of indicator of compromise. Attack technique timeline reconstruction. Threat hunting with technique-based queries. Microsoft Defender ATP. Advanced hunting with attack context. Custom detection rules mapped to techniques. Threat analytics with attack intelligence. Incident investigation with technique attribution. Training and education applications. Module 1 framework fundamentals. Module 2 detection development. Module 3 incident response integration. We have hands-on exercises, technique identification giving log examples, and map to attack techniques. Attack chain reconstruction, reconstruct attack progression using attack. Red team training. Attack-based scenario development. Scenario planning framework. Select target environment characteristics. Choose appropriate threat actor model. Map attack progression through attack tactics. Identify evasion techniques for each stage. Plan detection bypass and countermeasures. So some of the paths and the duration, right? Measuring implementation success. Maturity assessment framework. Level 1 basic awareness. Success. Level 2 operational integrity. The detection rules mapped to the attack techniques. So you're only going to be looking at those certain attack techniques that you're actually wanting to look at the most, right? Success. Level 3 strategic implementation. What is that? Comprehensive control coverage assessment using attack. Red team exercises planned using framework. Using this attack framework, right? Threat modeling incorporates technique analysis. Security investments justified through technique coverage. Success. Complete control over the assessment, right? That is also going to be documented. Level 4. Advanced optimization. Automated technique detection and response. Predictive analysis of likely attack progressions. Custom techniques development for organization-specific threats. Industry contribution to attack knowledge base. And then we have KPIs. Detection coverage and like the techniques, right? False positive. Operational effectiveness. Incident attribution accuracy. So figuring out who attributed to this attack. Was it like Russia? Was it China? Was it the United States? Stuff like that. But risk reduction, investment ROI, stakeholder satisfaction, and industry recognition is like how it's going to impact you strategically, how you operate, right? Being able to implement it, right? Technical challenges, data quality, and completeness. Challenge is insufficient or poor quality data for technique detection solutions. Tool integration, how you incorporate different APIs and stuff and tag everything. We have scale and performance. Challenge processing large volumes of data for technique analysis solutions. Organizational challenges. Staff training and adoption, right? They challenge the team to actually learn these attack frameworks, right? Resource constraints. Limited budget, time, or personnel for attack implementation solutions. Cultural resistance. Challenge organizations reluctant to adopt new framework solutions. Start with pilot programs and demonstrate value. Align attack implementation with business objectives. Communicate benefit in a business language. Celebrate success and share positive outcomes. Future framework. We have IoT, OTICs, mobile platform enhancements, container serverless, and multi-cloud tactics. AI, ML, some type of machine learning, quantum computing, edge computing, and I would say AI is an emerging technology as well. Industry verticals, healthcare, financial, and critical infrastructure. AI and machine learning. Oh, that's AI, ML. AI and machine learning. Enhanced granularity, sub techniques, and platform-specific variations, contextual metadata, and defense mappings, right? This goes more into automation with artificial intelligence and machine learning. Automated technique recognition. AI identifies techniques from raw data. Predictive attack modeling. Machine learning predicts likely technique progressions. Natural language processing. Extract techniques from threat reports. Behavioral pattern recognition. Advanced anomaly detection using attack. Extended reality training. which I don't know how that relates to security. You're going into virtual reality. I don't understand that. But they do it. They go into like these virtual reality headsets and stuff. Augmented reality. And I don't even think that's going to come up on the test. Industry standardization. Regulatory integration compliance frameworks. But it's still cool to know about that they actually do that. But why would you want to be strapped into a virtual reality headset learning about attack frameworks? I don't know. But I'm sure some people have done that. Regulatory frameworks, integration, commercial ecosystem. Conclusion. The MITRE ATT&CK framework represents a fundamental shift in how the cybersecurity community understands, communicates about, and defends against cybersecurity threats by providing a common language and structured approach to adversary behavior. ATT&CK enables organizations to transform security operations, enable effective collaboration, and drive continuous improvement. Key implementation recommendations. Start with education. Ensure team understands framework fundamentals. Begin small and scale. And this is all the like recommended stuff. And the key thing, remember, attack is not just a framework, it's a mindset shift towards understanding adversaries and building defenses that address how attacks actually occur, rather than just blocking known bad indicators. This behavioral approach to cybersecurity represents the next evolution in defensive strategy and operational excellence. So that was MITRE ATT&CK framework. We're going to go to the next one, right?